All right, taking a look at number 26 here from section 8.5. The setup is pretty straightforward here. You're trying to find the perimeter of HJF, which of course means that you're going to need to find X and Y. And if you notice, I did not label it in the picture, but they tell you that GK is parallel to the base, so you can put both of those in. And anyway, you've got a side splitter theorem set up here. I would take this y out for the time being. You don't need that. But because of those parallel lines, you know that x minus 2 over 9 is going to be equal to 4 over x plus 3. So I would just go ahead and fill that in. So that's going to be x minus 2 over 9 is equal to 4 over x plus 3. Okay. Now, I think the reason people ask me about this is probably on the algebra end. You may not have expected to have to use algebra 1, but you notice here when you cross multiply, this is a FOIL problem. That's the quantity x minus 2 times the quantity x plus 3. So, yay, you have to do a little bit of algebra 1 here. You get x squared plus x minus 6 when you cross multiply that. And be careful because that's got to be equal to 36. Going the other way. And so anyway, remember when you solve a quadratic, you've got to get it equal to 0. So subtract 36 from both sides. And you've got x squared plus x minus 42 is equal to 0. Certainly you could drop that in the quadratic formula. I would probably just factor though. Remember, 9 out of 10 questions in your book that are quadratics can be factored, and this one factors really nicely. We need two things that multiply to be negative 42. And we need two things that add to be positive 1. And of course, positive 7 and negative 6 will do that. So remember, we've got two things multiplying to be 0 here. Zero product property says either the first has to be 0 or the second has to be 0. So if x plus 7 is going to be 0, that would make x negative 7. If there's the possibility of x minus 6 being 0, that means x would be 6. If you go back and look at the diagram, x can't be negative 7 because that would give us a negative side length right there. So x is going to have to be 6. So I'm going to go ahead and fill that in. 6 minus 2 gives us a side length of 4 here. Okay, and down here 6 plus 3 gives us a side length of 9. And what you notice here, this is a very misleading diagram. Notice you've got a 4 on the left and the right. You've got a 9 on the left and the right. This is an isosceles triangle. Okay. Really, the triangle should have been drawn kind of like this with a 4 and a 4 and a 9 and a 9. Maybe not to scale either, but that's really what's going on there. And then we've got a 5, and we need to find that other side length there, so I'll label that with a y. And now at this point, notice this is not side splitter. Don't stumble into that trap. Just take the little triangle. Maybe do a 4 on one side and a 5 on one side. Take the bigger triangle, go back there. You're going to have a whole side length there of 13. So we've got a 13 there and a y. And should be able to set up a little proportion there. Small over large, for example. You could do something like 4 over 13 is equal to 5 over y. And you can solve that. And I think you're going to get a decimal value. But anyway, you can substitute that in and solve it from here.